Hey guys, these are your notes on functions. We talked a little bit about evaluating. Now we're going to get into analyzing a function. So the first things you have to know are the words max and min. A max is where one turns and dumps out water. Just write this down, read it, and then I'll explain using a picture in the next couple of slides. So you might want to pause this and make sure you get it all written down. A function is said to be increasing if a positive change in x, meaning as x gets bigger, y gets bigger. That's what it means to be increasing. To show an interval of increasing behavior, you always use parentheses, never brackets. Your answer is the x values when y is getting bigger, and you'll see what I'm saying when I start doing some examples. A function is said to be decreasing if as x gets bigger, y gets smaller. That word is supposed to be negative right there. I don't know why negative didn't come out, but it should be negative. Show an interval of decreasing behavior, we always use parentheses, never brackets. Your answer is the x values when y is getting smaller. Okay, so let's talk about this. First, before we do all of this stuff, I want to talk about the domain. The domain of the function is, remember, these arrows mean it goes on forever. You'll know if it's an asymptote because it'll have a dotted line, or it'll show it getting close to 0 but not touching it. These do not have asymptotes. These go on forever and ever and ever. So the domain here would be negative infinity to infinity. This goes on forever and ever and ever. The range, so the range is if you did the flashlight, for instance, I think there actually is a flashlight. Spotlight. Whoa, cool. Not really what I wanted, but it's still kind of cool. Alright, anyway, let's get rid of the spotlight. If I put a flashlight over here and another one over here, and I shined it on the function, when would there be a shadow on the y-axis? Well, you can tell that when you go down, all of this y-axis would have a shadow, and all the way up. So the range here, but wait, all the way up, notice how it points down and both of the arrows are going down? This is the top of the function. It never gets bigger than this because the arrows show it going down forever. So this is the top of the range. So the range starts at negative infinity and goes all the way to positive 5. That's the range. Now let's get to the new stuff. The min, the max, the increasing, the decreasing, the constant. So a max, if you go back and read your notes, is when the function starts to dump out water. So you can see as you're coming along the function, coming along, here's where it dumps it out, right here. And then you go, and it dumps it out again right here. Those are the maxes. Those are the local maxes of the function. Now on your calculator, there's a button. If you go to second trace, which I believe is calc, and then you do left bound, second calc max, and you do left bound, right bound, it's the same idea as the zeros. As long as you go to the left of the max and the right of the max, and then you have it guess, it will tell you the value of this point. You're going to have the exact value of that point. So we're going to have to do it on a calculator. For this particular one, we're going to call this point -3, 2. I know it's not exact, but for our purposes right now it is. 1, 2, 3. We'll call this 3, 5. Again, I know it's not exact, but I don't have the function in my calculator right now. So if it says max, that's what you would put. The maxes are -3, 2, comma, 3, 5. The min is when it turns and starts to hold water. So that would be right here at 0, -4. Okay, hopefully those are pretty obvious. I'm not really worried about local max and min and absolute max and min. These would all be called local. This one, in addition to being local, it's also the absolute maximum because the graph never, ever, ever gets bigger than this. This is called a relative minimum because it's the minimum between here and here, but it's not the absolute minimum because this goes down to negative infinity. So these are called local maxes and mins, and this is an absolute max. But again, don't stress too much about that. Now for the really important part. On what intervals is the function increasing? So the trick here is your answer is going to be x values, but what you're really looking at is when is the y increasing. So if I started down here, or way over here, where x is negative infinity, the graph is down at like negative 1,000,000, but it's still getting bigger and bigger and bigger as I come across the graph. So where is that, like, I guess this is like a highlighter. So it's getting bigger and 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 bigger, right to there. So I'm going to say it's increasing from negative infinity, and remember I'm talking about the x values, not necessarily just the y values. It's increasing from negative infinity all the way to negative 3. Then it starts decreasing, 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 right to here. Starting here, it starts getting bigger and bigger and bigger again. So from 0 to 3, the graph is getting bigger again. And then it goes down all the way to infinity, to negative infinity again. So these are the areas where it's increasing. I know it's a tough concept. Hopefully that makes sense to you. Okay, so let's talk about when it's decreasing. The function is decreasing from here to here, and from here all the way down to there. Meaning as x goes to the right, y gets smaller and smaller and smaller. So we would say it's decreasing from, and again, our answer is the x's. The question is, on what x values is y getting smaller? So we're going to go from negative 3 to 0, union 3 to infinity. And the graph is never constant. When a graph is constant, it looks like this, a straight line, straight across. Okay, so this graph is never constant. So all we're going to talk about for today is max, min, increasing, decreasing. So hopefully those make sense to you. Let's talk about this one. The domain, again, if I had my flashlight and I went on the x-axis, meaning I had a flashlight up here shining down and a flashlight down here shining up, eventually this is going to go forever and ever and ever and ever, I would get to all x values. There's never an asymptote, and there's never anywhere that the x isn't defined. So the domain would be all real numbers. The range, again, it's going to go all the way up and it's going to go all the way down. So the range is also negative infinity to infinity. A max, this is where it starts to dump out water, so that's a max. And then a min, why is that not erasing? What is going on? Whatever. A min is where it starts to hold water right there. So the max, we're going to call that point 2, negative 3. Now again, on your calculator, you would go to second calc max, and you would do a left bound and a right bound, and have it guess, and it would give you the exact max. And now the min, we're going to call that 4, negative 3. Where is the function increasing? Well, it's increasing from negative infinity, because remember, as I go farther and farther down, I'm also getting, my x is also getting bigger. So I'm going to increase from negative infinity all the way up to this point right here, which is 3. Union, well, it's decreasing in here, but then it's increasing from the minimum all the way up. So from 4 to infinity. And you'll start to find that your values of increasing and decreasing change at the maxes and mins. That's where it stops going up and starts going down, or vice versa. So this function is only decreasing between here and here. All the rest of the time the y values are getting bigger. So it's decreasing from 3 to 4. And I'll say it again. these will never have brackets because we want to know when is the function changing. So it's never equal to something because it's always changing. Okay, let's check this one out. Domain. So shadow, shadow, shadow. If I start down here, it goes all the way there. Notice there is no graph right here. There would be no shadow when x equals -2. So the domain goes from -infinity to -2, and then it stops. And then it goes from -2 to 2, and then it stops. And then it goes from 2 to infinity. The range, well, you can see that there are asymptotes here because it gets really, really close to that line but never touches it. And here it gets really, really close to that line and never touches it. I know it's kind of hard to see, but once we do more of these, you'll start to realize that this is a horizontal asymptote. So y is never going to be in this range. So the range is all the way down at -infinity, all the way up to -2. And then from 0, and that's actually a bracket because it does equal 0. All the way up to infinity. Here's a hint. The range is the only thing when you evaluate a function that you write the y values down. Everything else, these are coordinates, these are x values. The range is the only time you ever give the y values. So that's just a little trick. Hopefully you watched the video and you know that. So the range is all the y values from -infinity all the way up to here, because these are asymptotes at -2. And then there's no y values in here. And then from here all the way up. These blue dotted lines are just asymptotes. They're showing you the line that it approaches but never touches. Hopefully on future notes and stuff I'll have the horizontal asymptotes drawn too so that you can see. But you're just going to have to take my word for it here. Okay, the max. Well, it goes... how do I explain this? For this one here, I realize it's dumping out water, but it's dumping out water the entire time. It never changes from holding water to dumping out water. So there actually is no max here. There's also no max here. This one is only holding water, so there's no max here. So there is no relative max. There is an absolute max because it goes up to infinity, but there's no relative max. The min is this point right here because it stops and turns and starts holding water. So the min is 0, 0. Now, increasing. When is the graph getting bigger? So you have to think about what's happening all the way over, because we always start at the left and go to the right for increasing and decreasing. So at -infinity, what is happening to this graph? Well, remember, it's going up. It's getting closer and closer and closer to -2. Even though it's never going to touch -2, it's still getting infinitely close. You can get infinitely close to a number and keep getting bigger without ever getting to the number. For instance, like if you're getting infinitely close to -2 and you're at -2.9 and then you're at -2.8 and then you're at -2.7, eventually you could be at -2.0000000000001. And it could keep, you could keep adding zeros infinitely. So that's how you get really, really close to -2 without ever actually touching it. But every time the x gets closer to -2, the y is going down. We're getting smaller. So it's actually decreasing from -infinity all the way till when x equals -2. So to -2. Then the graph hops up here. And now from here to the min, it's also decreasing. So it's also decreasing from -2 to 0. Then what happens? What happens right here? It starts increasing again. So it's increasing from 0 to +2. Now some of you are saying, no, it's increasing from 0 to infinity. The y value is going to infinity. I agree with you. But remember, these are just talking about on what x values is the y value getting bigger. So from 0 to 2, the y value is getting bigger. From 2, that's right here, all the way to infinity, the y value is actually getting bigger. As you start down here and you start going up, the y value is getting bigger and bigger and bigger and bigger and bigger. So it's increasing from 2 to infinity. I know it's really hard. We're going to practice a lot. But hopefully if you watch it again and listen again, it'll start to make more sense. Okay, next slide. Okay, the domain here, if I shine a flashlight up here, it will touch the x-axis the entire way. So the domain is all real numbers. So you would go negative infinity to infinity. The range, it never is going to get down here. It's only going to go from here up. So it's from 4 to infinity. That's a parenthesis. Okay. There is no max because it's only getting bigger and bigger and bigger and bigger. I'm not even sure you would call this a min necessarily. I guess it is because it's the smallest value. There's no value in this whole function smaller than this value. So the min is 0, 4. Okay. Again, we're going to start at negative infinity and come this way. What's happening to the y value as I'm going from negative infinity to 0? The y value is getting smaller and smaller and smaller. So we're going to say it's decreasing from negative infinity to 0. From 0 over, the y value is getting bigger and bigger and bigger and bigger. So it's increasing as you go from 0 to infinity on the x-axis. No max. Okay, I think this is our last one. Yeah, last one. Okay, the domain. The x's exist everywhere except this asymptote and this asymptote. So for the domain, we would say negative infinity to negative 1 union. What is going on with that bell? Negative 1 to 2 union 2 to infinity. Because x can never equal negative 1 and x can never equal 2. So it's all those. The range, if you look, the range is all real numbers because it appears like it's x equals 0 is an asymptote. The x-axis is an asymptote here and here, but it actually equals 0 right here. So the range hits every single number from negative infinity to infinity. There is no max because even though it starts to dump out water, it never fully turns and goes down. It's always going, well, it's actually from left to right, it's always going down. So there is no max. There's also no min because it never turns and holds water. So again, we're going to start at negative infinity. And as I come and as my x gets bigger, my y is getting smaller and smaller and smaller and smaller. So it's decreasing from negative infinity to negative 1. Then I pop up here and I'm decreasing again from negative 1 to 2. Then my graph comes up here and it's still decreasing from 2 to infinity. So it's always getting smaller, because remember we always go from left to right. It's just you can't, the function is not defined at negative 1 or 2. So those can't be in your interval of increasing and decreasing. I know it's hard. Hopefully you can watch this again and it'll make sense, and we're just going to practice in class on Friday. Okay?